Question is the resistance of the platinum wire of a platinum resistance thermometer at the ice point is 5 ohm and at steam point is 5.23 ohm. When the thermometer is inserted in a hot bath, the resistance of the platinum wire is 5.795 ohm. Calculate the temperature of the bath. So, at the first sight itself, it is very clear that the question is about the temperature dependence of the resistance. The resistance of the platinum wire is given at two different temperatures. That is, at the ice point, the resistance is 5 ohm. Ice point means temperature is 0 degrees Celsius. That is, at 0 degrees Celsius, the resistance is 5 ohm. At the steam point, the resistance is 5.23 ohm. Steam point means 100 degrees Celsius. Therefore, at 100 degrees Celsius, the resistance of the platinum wire is 5.23 ohm. Now, the thermometer is inserted in a hot bath and it is found that the resistance is 5.795 ohm. We have to calculate the temperature of the bath. So let us use the equation for temperature dependence of the resistance, that is RT is equal to R0 into 1 plus alpha into T minus T0, where RT is the resistance at temperature T, R0 is any reference temperature, alpha is temperature coefficient of the resistance. But the value of temperature coefficient of resistance alpha is not given in the question. So first we have to find out the value of alpha. But here we are going to solve this problem not by finding the value of alpha, but having an equation for alpha. So let us first have an equation for alpha. From the given equation, RT is equal to R0 into 1 plus alpha into T minus T0. So to have an equation for alpha, let us bring all the terms except alpha from RHS to LHS. First bring R0 to LHS. It will become RT divided by R0 is equal to 1 plus alpha into T minus T0. Next, let us bring 1 to LHS. The equation will become RT by R0 minus 1 equal to alpha into T minus T0. Or LHS, we can write RT minus R0 divided by R0 is equal to alpha into T minus T0. So, alpha we can write RT minus R0 divided by R0 into T minus T0 is equal to alpha. So we have got an equation for alpha. Next, in this equation we need two resistance values, that is RT and R0, and two temperature values T and T0. So let us take two sets of temperatures and resistances. Before that, let us write all the values given in the question. The resistance at 0 degrees Celsius is 5 ohm. The resistance at 100 degrees Celsius is 5.23 ohm. The resistance of the platinum wire when inserted in hot bath is 5.795 ohm, and we have to find out the temperature of the bath. So first let us take two sets of temperature and corresponding resistances. Let us take reference temperature as ice point and temperature T as steam point. That is T0 is equal to 0 degrees Celsius. Therefore R0 is resistance at 0 degrees Celsius, that is 5 ohm. And T is equal to 100 degrees Celsius. Therefore RT is resistance at 100 degrees Celsius, that is 5.23 ohm. Substitute all these values in the equation for alpha. Let us write alpha is equal to RT minus R0 divided by R0 into T minus T0. Putting all the values, we can write 5.23 minus 5 divided by 5 into 100 minus 0. Or 100 minus 0 is 100 itself. We can write alpha equal to 5.23 minus 5 divided by 5 into 100. This equation, let us call it as equation 2. Next, again let us take another two sets of temperature. That is, in this set, we can take reference temperature T0 is the ice point itself, that is 0 degrees Celsius, but temperature is equal to TB, that is temperature of the hot bath. Therefore, the resistance R0, that is resistance at T0, is 5 ohm, and resistance RT is the resistance at temperature TB, that is when inserted in the hot bath, that is 5.795 ohm. Put all these values in the equation 1, that is equation for alpha. Let us write alpha equal to 5.795 minus 5 divided by 5 into TB minus 0, or 5.795 minus 5 divided by 5 into TB. So we have got two equations for alpha, that is equation 2 and equation 3. Let us equate equation 2 and equation 3 because both equations are for same alpha. So we can write 5 minus 5.23 minus 5 divided by 5 into 100 equal to 5.975 minus 5 divided by 5 into TB. From both sides we can cancel 5. Then we can write 5.23 minus 5 is 0.23 divided by 100 is there. 5.975 minus 5 is 0.975 divided by TB is there. Or TB we can write 0.975 into 100 divided by 0.23. We will get the answer as 345.65 degrees Celsius.